For my RET lesson, I'm going to start you off with an idea of what standards are covered. So the big concepts are properties of matter. That shows up in a lot of standards. So I teach chemistry and physical science. You could use this for either. You could also use this for middle school easily just by adapting it a little bit. But properties of matter, energy transformation, and we'll come back to this standard because they'll come up during discussion. In my lesson plan, we're starting with engage. So for the engage, there's two parts. So I've made a snap circuit that students will be able to see, and as you can see, it lights up. And their challenge is they're going to recreate this snap circuit. So we have a little bulb. We have the batteries. We're sharing batteries today. So we have the snap circuit batteries, which are enclosed, which is a nice little feature, so you don't have to worry about them. And then if you want, we have this optional switch piece. So they're going to try to recreate this using a different set. So this is squishy circuits. So the engage is going to open up with having those set out, and they get to look at it, try to figure out what parts there are. And then the other piece of the engage is we are going to be making dough that we're going to be using to connect these parts in order to make the light up. So I'm going to need 4 volunteers. Let me explain the station first. I've got our Ziploc bags with the ingredients printed on with the amounts that you need. I also have the measuring cups that you need in front. So like you just need to use one of each and you'll be good if you like don't feel like reading, which, you know, sometimes that's how students vibe. Okay, so while they are going to be mixing your dough, so you're going to put your ingredients in this order. The order doesn't matter, but you know, dry and then wet is always nice. You're going to knead it in here, so there's no need to equipment. And for if you wanted to, you know, science it up a little bit more, you could easily do this in grams and use your lab scales and practice those skills as well. All right, so volunteers come up, and while the volunteers are coming up to make this dough, I'm going to talk about this dough I already made. So yeah, you guys can walk across, do your mixing. All right, so I made this. We have 2 types of dough, and we're going to be talking about the differences between them. So I made this one. I pre-made this one. I would make this in my classroom, but it requires heating, so that just wasn't an ideal setup here. So for this one, I'm going to talk about the ingredients. So for this one, I have the flour. I also have the vegetable oil, water, but this one also includes cream of tartar and some sea salt. And then all of those ingredients were mixed and then heated up. So while the class is mixing their ingredients, what we're going to do is we are going to review the types. So this is all made of stuff. And like, what's our fancy science word for stuff? Matter. So we're going to be reviewing types of matter. So what are the 3 basic types of matter? Not that category. So not states of matter, types of matter.
Metals?
That's a good guess. I'm looking for more basic than that. Elements. All right, so we've got elements, compounds, and what's our last one? Mixtures. Excellent job. Okay, so what we're going to be doing while we're mixing them is we're going to go ahead and review. So physical chemistry really builds on itself. So we're going to review these, and we're going to sort our ingredients into the type of matter it is. So let's go ahead and let's start with our water. So what type of matter do you guys think this water is? Compound. How did you guys know that? H2O. So when we have one formula, that's going to be a compound. So compounds can be described by one formula. So can elements. Mixtures, we can't do that. What about our sea salt? And we're imagining this is a perfect world, right? So these are food ingredients from the grocery store. We all know there's legislation about how many cockroach legs can be in there. But we're imagining a perfect world where that doesn't happen. So ideal compound. How did you guys know that? It has a formula. So NaCl. We're assuming this is NaCl. There's a lot of different kinds of salts. I mean, in all reality, the sea salt, if it's really from the sea, probably a mixture, but idealized. Okay, what about our sugar? What do you guys think? Compound, yes, we also do have a formula for sugar. Anybody know that one? Yes. I think that's one of the sugars. Yeah. But there's a lot of different sugars. I'm going to assume we have this one. And again, realistically, our sugar, anything you get from the grocery store, probably a mixture. When scientists source ingredients, they actually pay a lot of extra money to make sure it's super pure. And the more decimal places you have for how pure it is, the more money you pay. But this was very cheap at grocery store ingredients, so this is a very accessible lab. All right, we also have our flour. What are you guys thinking? Mixture, because how do we make flour? What does it start as? Yeah, a plant that we grind up, right? And plants have a lot of different parts that you can see. So when we grind those up, it's definitely going to be a mixture. Like you have different kinds of flour that vary depending on the properties of that mixture, right? So like if you're making bread dough or pizza dough, you want more protein. But if you want to make like cake, you want less protein. So there's proteins and starches, lots of stuff in there. So we're going to put our flour over here in mixture. And then our last ingredient, oh wait, we have two more. We have the vegetable oil. What do you guys think? So oil can be a compound, but how do we make this?
It's a mixture.
Mixture, and also think about vegetable oil you buy at the grocery store, right? A lot of times it has oils from lots of different plants, like it'll be sunflower and canola. So especially since it's not one kind of plant labeled, we're definitely going to say mixture. So oil, even in our idealized world, definitely the oil is going to be a mixture. All right, so last up we have cream of tartar. What do you guys think? Compound, anybody know that formula? It's okay, I got you. I got it written down already because I didn't know that one either off the top of my head. All right, so we've got, oh, sorry, not element, compound. So this is KC4H5O6. So that's our cream of tartar. Okay, so we are going to, and you guys can, pick whichever, you guys already did that, great, picked a color. We also have the food dye, but we're just adding 1 or 2 drops. What do you guys think for the food dye? It depends. It's probably a mixture because it's a solution, so it's probably a chemical in water. And depending on the color, remember when we did, if you've done chromatography where you do like a coffee filter and a dye, a lot of times it'll separate into different parts. So probably a mixture, so food dye. And whenever we're talking about real world stuff, these categories get a lot more muddy, especially when we're talking about compounds. They tend to not actually really be pure. So we didn't have any elements. Let's talk briefly about those. How would we know we have an element if you knew what it was? What's a big clue? Yeah, so when you look at the formula, it's going to have just one capital letter. So like O2, Cl2, or just chlorine. So it only has one type of matter, one type of atom. And you're also going to find it on the periodic table. So if you see something like iron, that's on the table, you know that's going to be one of your elements. Okay, so let's go ahead and how are you guys doing with your dough? All right, so I guess we're going to pause and we are going to let them mix their dough for a minute. So go ahead and try the unheated ones you guys just mixed. Shouldn't matter which one you try to complete it with. So you guys will have to talk about what you guys think you need to do with these parts to make it glow like this one. All right, so you guys put it in the whole big ball of dough. Is it lighting up?
No.
Okay, do you guys want to try less dough?
Yes.
All right, let's try it one more time with this one and let's try less dough. Okay, so we do have to connect them all up. You guys are right about that. Let's see if using less dough makes any kind of difference.
So, I got a little ball there. Ball. Stretch out a little bit. Like one side and that side. Do we want to put a switch on it?
Sorry, I didn't
Let's
mean to
make it
stab
light
you.
up first.
I'm trying to study.
Yeah, the
Before we
switch
get
is
fancy with a
optional. So this one does not have a switch. So you do not need one. So it is cool.
Okay.
Think it's on there?
And then there's another ball of dough. Kind of wrap it around.
Dough can't touch each other.
I know.
Oh yeah, so you guys think maybe they can't touch each other. So let's try separating them out and see if that fixes it. All right, so you guys have them separated. You just have a little bit of dough.
There it
There's
goes.
a
There it
light.
goes.
Interesting. Okay, so it did light up. So we do have a light here. So it's flashing. That's pretty cool. I didn't know it would do that. Okay, so let's go ahead and let's try this one. So this is the heated dough I made. All right, so here you guys go. Try the same setup.
Ooh, wow.
Ooh, what do you guys notice about that light?
Way brighter.
It's not even.
It's
barely
way
in there.
brighter. Interesting, because I think you guys did a really good job making your dough. So I wonder why this one's so much brighter. All right, and now let's try our last one. Okay, so this is this dough, but I left it outside to get really dry. So let's see if it still works as well.
Okay. Wow.
So it still works pretty well. Now, would you guys say that dough is completely dry after handling it?
No.
No, so it still has a little bit of moisture.
Yes.
All right. Yes, what kind of qualitative observation can you make about it compared to the other ones?
It was dim. It was much dimmer.
Yeah, so it was a little bit, it was dim. What about the heated one?
Bright.
So it did glow and it was bright.
The brightest.
Yeah, so we could do a qualitative one, or we could do it, what's the other kind of data we can do? Quantitative. So let's go ahead and say this one is the brightest, so it did glow. And how could we translate this to a quantitative data if we wanted to? How could we describe their brightness as numbers?
Put it on a scale.
Yeah, put it on a scale. So what do you guys think? 1 is the brightest or 3 is the brightest?
3 is the brightest.
Okay, so this is going to be 3, this is going to be 2, and this is going to be 1. So let's talk about the differences in these dough. So both of the doughs had water, oil, and flour. One of the doughs had sugar, that's the one you guys mixed together, and then the other one had sea salt and cream of tartar. So what do you guys think caused this dough to be brighter? What could explain that?
The reaction between the cream of tartar and the sea salt.
Yeah, it's ionic. So that's the other thing we're going to be reviewing today. Bonds. So ionic bonds. What do you guys remember? What are they good at sometimes? Conducting. But what has to be true for them to be good conductors?
Free moving of electrons.
Yeah, so they have to have free moving electrons. Now, this one was the same dough, but it wasn't as bright. What do you guys think's going on there? How can we explain that with the kind of bond it is? What's important for ionic bonds to be good conductors? Yeah, they need to be able to move, so they need to be in solution or have some moisture, right? So this dough is nice and, so a lot of times batteries, like they aren't gooey inside, right? So batteries use ionic compounds. Like think about the names, right? Like they usually have like a metal name and then there's another compound. So they're usually in a paste and that allows the electrons to move. So that's why the dry one, so has to be liquid or a paste. So what do you guys think? If this completely dried out, do you guys think we could get it to light the bulb? Probably not. So this, what's the bit? So we have conductor. What kind of dough is the other kind of dough? What's the opposite? Yeah, so it has a covalent bond, so that's the kind of bond it has. So it has a covalent bond, so flour and sugar and oil are all organic compounds that have a lot of covalent bonds. So is water. Water is covalent, though. Water can also conduct electricity. Don't be swimming around in a swimming pool thinking you're safe in a lightning storm. So covalent. And what's the opposite of a conductor? Insulator. Now let's look at the snap circuit. What does it have completing the circuits? It doesn't have any dough. What do we have here? Metals. So that's our third kind of bond. We also have metallic bonds. So what state of matter is that metal in? Yeah, it's a solid, right? We don't have any hot liquid metal. That would be dangerous. So it is also a conductor, and metals are extra good at conducting. So they're going to be a good conductor even when they're solid. So this would be, this in my chemistry classroom would come after we've done the three kinds of bond, and we review those properties and also an example. So we're going to explain by talking about the kind of bonds. And then we would go ahead and we would have a bigger class discussion about like the different parts of a circuit, like what we think they do. But we're going to skip that and we're going to talk about the next part of the lesson plan. So for the elaborate, we would have a choice menu. So we've already covered in depth the chemical properties that make this possible. So again, physical sciences build upon each other. So we have to know what kind of matter it is, if it's an element, compound, or mixture. And then we have to know what kind of bond it is, and that's going to help us predict what's going to work well in this circuit. But in the elaborate, we're going to learn more about electricity itself, so we're going to hit more of those standards. So they're going to have a lot of choices, including the snap circuits. So the snap circuits, they're going to have an option to build different units. So they have noisemakers. You can do that instead. I don't recommend it for obvious reasons if you have a classroom full of them. They have a little fan that goes up. They have all kinds of things. Also, another option on the choice menu is going to be the squishy circuit. So there's a lot more units in here that they can make, and this one's kind of a little bit less intimidating, and there's a little bit more artistic expression involved. Another one of the choice menus is going to be they can build a wind turbine, and that's, again, okay, the base fell off, so don't hold it like that. So they can build a wind turbine. So one of the big concepts we're going to be covering is energy transformation. So with the wind turbine, what kind of energy are we turning into what kind of energy? Mechanical into, yes. What about with both of our circuits? What kind of energy are we? Chemical into electrical. So the chemical energy stored in the batteries. So there's going to be a lot of energy transformation options there. And there's going to be some other options, and all of these options are kits available to check out from ECU. So everything you see up here, except for the things you can get at your grocery store, you can get for free from ECU. Now the snap circuits, they're not a class set. You'd have to get a couple of these boxes. But the squishy circuits is a full class set. It does come with the dough, and it does come with an insulating dough. So I haven't used the insulating dough that comes with the kit. I'm not sure if the light was supposed to be on at all. It might have been, you guys. What do you guys think might have been why it was able to conduct a little bit of electricity?
A little more wet from our moisture.
Yeah, like your sweat from your hands, right? You guys have salty sweat. Also, you guys added a lot of food coloring. So one of the secret ingredients in the insulating dough is actually the water is different. So for this dough, I use regular tap water, but for this, I use deionized water, which is going to have all of those minerals and salts taken out, so it's going to be less good at conducting. All right, so that's it. Thank you, guys.